Hi, Joel Rollins here for Rave Radio on day 3 of ISE 2016, and I am in the Calibre UK booth with Tim Brooksbank, a longtime consultant to me on the scaling market. Tim, thanks for being with us.
Hi, Joel. Good morning. It's lovely to see you here.
Well, thank you. Actually, it's great because behind me is a Pac-Man game that just defeated me fairly severely. So, and I would have thought that I remembered how to do this because I used to be a Pac-Man high scorer, but I can't do it anymore.
I've just seen a high score up there that's pretty good, 11,740. Was that you?
No, I think mine was 6.
Ah, that's better than me. I get about 300.
Anyway, Tim, we have an enormous amount of progression going on in the market now. 4K is obviously the hot topic here this year. I know that you've brought a lot of 4K product with you. What's new at Calibre?
We've got a whole new range of products for 4K. We have our new HQ Ultra range of scaler switches, which include our HQ Ultrafast technology. Now, HQ Ultrafast is our 4K scaling and switching technology that's able to switch input channels in typically a quarter of a second, which is absolutely awesome. It's an order of magnitude faster than most solutions out there running on a single scaler. So it's a single channel scaler with the kind of cost effectiveness of a single channel scaler, but with the switching speed of a multi-scaler product.
I just built a home studio with 2 4K cameras, and the speed of switching between them says that a 2-camera studio isn't really all that useful because you can't do it live. I was amazed over here at how quickly you could switch and how cleanly you could switch between sources.
It is awesome, and we've rolled this technology out into a whole range of products now, some of which are brand new for this show. We now have a suite of 4 different products with this in for LED screens, because LED screens, as you can see in this hall, in Hall 11 where we are the in thing now. LED screens have come of age. Everyone is putting LED everywhere. So we have LED optimized versions of these, which use a very, very powerful scaling algorithm that we developed in-house that gives absolute best-in-class image quality on the LED screens at arbitrary resolutions. And also we have our HQ Ultra products, which are designed for things like presentation, education, boardrooms, this kind of thing, even house of worship, which have the 4K scaling switching targeted at flat panel displays and projectors. And these are all available with audio as well. So now we have analog audio routing and switching in them, programmable audio follow video, balanced line out, and inbuilt power amplifiers as well for driving speakers in smaller boardrooms.
Well, one of the things that has always been a problem for me about 4K, I mean, number one is that just now, real product is becoming available. The other has been that when driving an LED wall, you almost never wind up on the preset. You don't wind up at 1920 by 1080, you don't wind up at 4K, you wind up at some intermediate resolution. How do you deal with that?
Well, that's straightforward. You see, LED screens are built out of tiles, and each tile has a fixed number of pixels. So the resolution you end up with depends basically on the booth designer or the set designer or the architect if it's in a building. So we have scalers whereby what you can do is you can set we call it an output window, which some people refer to as an output area of interest. And you can independently drag each edge of the image to a precise pixel position to set the size of the image to suit the LED screen that you've built. And then every input channel, whatever the resolution is automatically scaled to fit that output window size. Even if it's 4K or HD or even SD, it will automatically be resized by the scaler dynamically to fit that output window size. We can, in fact, drive LED screens from anywhere from 4096 pixels by 2160 pixels all the way down to 128 by 96. In fact, I was showing someone earlier here, we can take a 4K image in, scale it down to 128 by 96, and you can still view the picture.
For what? So you can display it on an Apple Watch?
Well, actually, it's the main use of that. I know it sounds crazy. I think Apple Watch probably has more pixels. The main use for that is sometimes in retail where people want to put arbitrary tiles in shop window displays and so on, and they want to put an image on a very, very small surface.
Let me ask you some technical questions about 4K, since you know more about it than most people I would know. We have in the U.S., there's an enormous amount going on in how 4K is going to be transported. I see it on DisplayPort, and everybody says, we have one faction that says DisplayPort will be the way we transport it. Another says HDMI will. I've even seen it on 2 HDMIs. How is that going to shake out?
I believe HDMI has won. I firmly believe that. DisplayPort exists. It's there. People want it as an input device on our kind of, an input standard on our kind of product, because they want to be able to connect something like their Surface Pro 3 or their Mac that has native DisplayPort out. But in terms of output, people have moved on from it. All the newer 4K projectors have HDMI inputs on them, HDMI 4K inputs. All the new flat panel displays have HDMI 4K inputs. LED is still catching up. The LED driver boxes, they are probably about a year off having HDMI 4K input channels on them. But without a doubt, HDMI has won, whether we like it or not. There are loads of us out there who are technical, who say, well, DisplayPort is technically better, the protocol is superior, the connectors are superior. It doesn't matter. The market has chosen HDMI. And I think there are two reasons. One is because backwards compatibility has won yet again. And the other reason is HDMI is easier to get a longer distance than DisplayPort. Now, I never thought I'd be saying that when HDMI came out about 10 years ago and we were all bemoaning how short a distance it would go. But the solutions for driving HDMI a longer distance are mature and work well now, whereas the solutions for driving a DisplayPort a long distance are very, very rare and frankly are a little bit shaky. And I think that's why HDMI has won, because as a transport mechanism, we might not like the connector, we might all moan about it, but it does work.
Well, okay, as you know, I come from a staging background, and I'm thinking about things like cable inventory, connector inventory. In order to accommodate 4K, you know, my projectors now have 4K inputs on HDMI, but do I need different cable, different connectors? Am I going to have to be careful about cheaper HDMI cable not working?
That's a good question. I think you will find that cheaper HDMI cables may have issues. If you've got a decent HDMI cable, then I think it should work. You know, the biggest weakness tends to be the terminations in the plugs. It's down to how well that's made, how good the screening is in there, whether the cables have been terminated at accurate equal lengths, things like that. Some of the cheaper cables don't have shielded connectors underneath the plastic. It's that kind of thing more than the piece of wire. But also, you can have the reverse true. Some of the very, very expensive big brand cables have these gigantic connectors on them, which look fantastic. And they charge you huge amounts of money for them. I'm not going to mention the brand, but we all know it. And they're actually too heavy for the sockets they're going in. So you have a different problem. Electrically, they're brilliant, but you get bad contact because they literally lever themselves down on the HDMI connector in the product, and you end up with a bad contact. And actually, you can get worse performance with them unless you do something to hold the weight of the things.
We call that strain relief. And you know, we like big heavy cable we want to be able to roll forklifts over it and not worry about it. Big heavy connectors to us look like they're going to be sturdier in the long run, but I can see your point there where some of them actually do drag things down. As a matter of fact, I've had to tape an Extron switcher to the table to keep it from being pulled off by heavy cables.
I think the other thing that's coming of age now as well is 12G SDI is real. So for the stagers, what they're wanting now is that they're seeing 12G SDI as the standard they're going to go for. So we're going to go back to where we were in the past with HDMI for the consumer, prosumer market and for the IT market, and we're going to go back to SDI, but it's going to be 12G SDI, which is 4K 50 or 4K 60, 422 down a single coax cable, and it's real. And our current products that we're shipping, they have 4K HDMI in, 4K DisplayPort in, but 3G SDI in. Our next generation of product, which you'll see this show next year, they'll have 12G SDI in and out.
Well, I do love SDI. My problem with it is you're so often on a show given componentry, especially client-supplied componentry, that's like, okay, now I've got to convert all this to SDI if I'm going to use it, and you wind up with kind of a hodgepodge. So in order to move 4K properly, we're waiting for another SDI standard?
Well, the 12G SDI will correctly move 4K. There have been some products launched by some manufacturers already at 12G SDI, but they're taking a bit of a risk because the standard was only just published, literally in the past few weeks. So we decided to hold off until it had been properly standardized to make sure that we weren't going to have issues with incompatibility and interoperability standards. So no, 12G SDI is real. It's going to transport your 4K. You will need decent quality coax cables with decent quality connectors, but you always did for SDI.
Yeah, that actually makes sense. Now, talk to me about 4K processing just for a minute, because we hear a lot about the differences in bit depth available through different 4K processors. For a large screen display, what am within reasonable cost, what am I really looking for?
One of the things you're looking for is you need to be concerned more about the bit depth internally in the processor than the external bit depth. Most 4K that's being transported at the moment is 8-bit deep externally. But what matters is what the bit depth is inside in the mathematical engine that's doing the scaling. Because if you don't have enough bit depth in the scaling engine, then as it goes through the successive calculations to scale, you get successive rounding errors, which means you don't get the result you expect. And that shows itself as fringing, banding, solarization on the screen, or generation of noise on the screen. Now, the other thing which a lot of scaler manufacturers don't get right, generally because they're using off-the-shelf consumer chips, consumer silicon, is how to deal with the gamma of the signal as well. So there are a very small number of manufacturers, Calibre is one of them, I know Barco is another, who understand that to scale really well, you have to de-gamma to linear data, and then you have to scale linear data, and you have to re-gamma, and that is very, very demanding on the bit depth, because de-gamma and re-gamma is a logarithmic function, so you end up with a very big fraction, which means you need a lot of bits. So our new scalers, our HQ Ultra scalers, 4K scalers, they actually dynamically alter the bit depth depending what they're doing and what they need. But typically, internally, the calculations are going on at between 14 bits and 16 bits per color per pixel bit depth.
I'm seeing a lot. Obviously, you walk around these halls, you see an awful lot of product that has had 4K labels put on it. Is there cheating product out there?
Yes. It's 4K, but not as you know it, Jim.
Okay. How does somebody cheat?
Well, generally, people aren't cheating and pretending they do 4K. They do 4K. The question is, there are two questions, and there are two ways of cheating at the moment. The first is there are people out there who do support 4K, but only at 25 or 30 frames a second, which is okay if all you're doing is showing PowerPoint, but if you want to show moving video, it looks kind of clunky. Sure. And there's a lot of product like that out there. The other thing that people are doing, there is product out there which will support a 4K 60 out, but not in. So they'll take HD in and upscale it to 4K 50 or 4K 60, but they can't actually ingest 4K. And there's another suite of products out there from a well-known manufacturer which can support 4K 50 or 60 out, but if they take 4K 50 or 60 in, they can't do anything with it. They're just a switching matrix. They can't scale it, they can't size it, they can't do pan, tilt, zoom, they can do no functions on it. They become a piece of wire. And to me, that's cheating.
All right, one final question. I'm a staging guy, come to the show, I'm looking at 4K product. I know that I'm going to need a significant number of 4K products in my inventory, so I am looking to save some money. How do you apply, what's the fastest acid test?
I think the fastest acid test is to say, first of all, does it take 4K in and out? Does it support 4K 50 and 60? Now, our current products and most manufacturers' current products that do 4K 50 and 60 support what's called 420 color space. Some people get hung up on this. If you're doing simulation, control rooms, you're probably right to be hung up on that. But in the video world, don't be hung up on it, because you know what? If you're showing 4K content that's been through any kind of recording, it's been recorded at 420, because those H.264 and H.265 codecs will have recorded it at 420 and will have played it back at 420. So don't get worried, it's going to look good. So you're looking at, does it support 4K 50 and 60? You're also looking at, does it have a few 4K inputs? Can it do things with the 4K? Can it scale it? For instance, if I have a HD projector, can it downscale the 4K onto my HD projector? If my client turns up with SD or HD, can it upscale it to my 4K TV? You're also looking at, is the motion good? Are they having bandwidth issues, which means their motion isn't good? you're looking at things like, is the color good? Are the edges of things good, or are they getting fringing and stepping on edges? And you're also looking at things like, if you're driving LED, is it able to downsize to arbitrary resolutions accurately without weird things happening?
Okay, well, that's certainly a good set of acid tests. Tim, just one final question. What's the stand number here?
The stand number is 11F36. Please come see us. We have on here our giant Pac-Man game and our giant Galaxians game. I kept calling it Space Invaders and got told off by some real gaming people that it's Galaxians.
I wasn't sure if it was Galaxian or Galaga because they're very similar.
Yeah, I know. I wasn't really a gaming guy. For those of you who are British and watching this, my gaming consisted of using a 1980s BBC Micro when I used to play the game called Elite. If anybody was from the 80s, you might just remember it. But come play the games on the booth, because we're actually running a competition that if you put your high score down on a business card in a jar here next week, we're going to look at who got the highest score, announce it on our Facebook page, and we're going to give away a 4K scaler to the person who gets the highest score of the show.
All right, I have to dig back into my memory and see if I can remember how to play. Tim, thanks for being with us.
Thanks, Joel. It's been great to see you again.